here we are with 1.9 practice help. Okay, so which construction can be used to determine whether point C is closer to point A or point B? Now, notice that we don't really have a diagram here, so you just have to imagine it in your mind, okay? So you have 2 points, A and B, and then a third point, C, and it could be anywhere. So the question is, how do you figure out whether it's closer to A or B? So you go through these and figure out which one of these would help you to figure out if a point was closer to point A or closer to point B. Pause the video, answer the question. Task 15. The diagram is a straight edge and compass construction. Lines L, M, and N are the perpendicular bisectors of the sides of the triangle. So that means that this line L right here splits A and C perfectly in half. It's a perpendicular bisector, right? And line N right here splits A and B perfectly in half. It's the perpendicular bisector of AB. And this looks like a ray from D out this way, ray M. This is perpendicular bisector of segment BC, cutting that one perfectly in half. Okay, so remember all the work that we did around the territories of the pizza shops in lesson 1 point. Heck, it was this lesson, right? All right, so you're just going to go through these and figure out what's what, right? Which one of these are true? It says select all that apply, so that means that there could be select all of the true statements. So anything that's true, you should put a check mark by it. Take your time, pause the video, and answer the question. Task 16. Decompose the figure into regions that are closest to each vertex. Explain or show your reasoning. Explain or show your reasoning. So what you're doing here is you're imagining that A, B, C, and D are pizza shops, and you need to come up with the borders between all the territories. Now, you won't be able to color them in like we did before, but you have to create all of the borders for that scenario if you have these 4 pizza shops. Okay? Task 17. Which construction could be used to construct an isosceles triangle? Again, isosceles means that has 2 sides that are equal to each other. Okay? Triangle ABC, given the line segment AB. Okay. So we have a line segment that is AB. Okay? All right. Which one or 2 or 3 or 4 of these statements would help you to make an isosceles triangle? Pause the video. Answer the question. Task 18. Select all true statements about regular polygons. Remember, regular polygons, right? We talked about what those are, right? There's regular actually means special, right? So go through trying to figure out which of these have to be true about regular polygons. Okay, pause the video and answer the question. Task 19. This diagram shows the beginning of a straight edge and compass construction of a rectangle. A rectangle, all right. So here's what the construction did. It followed these steps. It started with 2 marked points, A and B. So there was nothing here except for points A and B. Then it says make line AB. Great. Then it says make a line perpendicular to AB passing through A. Okay, so that gives us this line. and then use another construction to construct a line perpendicular to AB but passing through B. So now I have these two lines going up and down and this line going straight across here. Mark a point C on the line perpendicular to AB passing through A. That's that point right there. Okay. Now, if I'm going to make a rectangle, you have to explain the steps needed to finish this construction. And if you're going to make a rectangle, you need to list out the steps that you would need to finish the rectangle based on already having points A, B, and C. Okay? Pause the video, answer the question. Task 20. This diagram is a straight edge and compass construction. All right. All right. Question is, so task 20 is just the diagram. The question is actually for 21, right? Is it important that the circle with the center of B, this one right here, passes through D, and that the center circled at D passes through B, right? Does this circle here have to hit point D, and does this circle here have to hit point B? Is there another possibility in order to make our bisector of this angle, right? EF is bisecting this angle. It is cutting that angle in half. BAC is getting cut perfectly in half. So, is it a requirement that each of these circles hit the other point? And that's what this question is. Sure to explain your reasoning here with this.